Perpendicular bisectors. Let us learn how to draw a perpendicular on a line PQ and to prove that it is a perpendicular bisector for PQ. Taking P and Q as centers, let us draw two arcs of equal radii with condition that the lengths of the radii should be more than half the length of line PQ. If the radii are equal or less than half the length of line PQ, then they would not intersect each other. Now, draw arcs on both sides of line PQ. Suppose the two arcs intersect each other at R and S. Join R and S. Suppose the line RS intersects PQ at point O. Then, line ROS is the required perpendicular bisector. Let us now verify whether what we have done is correct or not. Let us join PR, QR, PS and QS. Now consider triangles PRS and QRS. Because R is situated on arcs of equal radii, side PR is equal to QR. Similarly, PS is equal to QS, and RS is common. Therefore, according to SSS congruency, we can say that triangle PRS is congruent to triangle QRS by SSS congruency rule. That means the angle PRO should be equal to angle QRO, because they are the corresponding angles of two congruent triangles. Recall arcs of equal radii. Angle PRO is equal to angle QRO, as proved above, and the line RO is common. Therefore, triangle PRO is congruent to triangle QRO by SAS congruency, because their two sides and the angle between them are equal. Now, we know that these two triangles are congruent triangles. Therefore, OP and OQ should be equal. That is, OP is equal to OQ. Therefore, the line segment RS divides the line PQ in two equal segments OP and OQ. But one thing that we have not proved yet is whether the line segment RS is perpendicular to the base PQ or not. We again take the help of corresponding parts of congruent triangles. Now, angle POR and angle QOR are equal, but angle POR plus angle QOR should be equal to 180 degrees because this is a linear pair, a straight line. Therefore, angle POR should be equal to the angle QOR. That means both the angles must be 90 degrees. So we say that line segment RS is the perpendicular bisector of line PQ.